Yes, sir. Good morning, students. In the previous video, we discussed about the third module. Okay, we completed the third module in the previous video, and this video will start with the fresh module, that is the fourth module, signal processing circuits. The fourth module is signal processing circuits. So, what exactly a signal processing circuit is? So, in the previous module, what we are discussed, they are all signal generating circuits. Okay, they will generate the signals. So, here the signals are processed. Generated signals are processed. That means, so if you want apply one kind of a signal as an input, we will get the other kind of the signal as an output. That is process. So, process will happen. That is why it is called as a signal processing circuits. Okay, so the rectifier circuits which are implemented with the diodes we already discussed in the previous semester, and it has got some of the limitations over the precision rectifiers. So what are those limitations? Okay, so the rectifiers which is designed using the diodes, it is not possible to rectify the voltage below 0.7 volts. So why? Because 0.7 is the cut-in voltage of the diode. So as we are using the diode, multiple number of the diodes in the diode rectifiers, so if you apply the input voltage less than the 0.7, even if they are not able to drive the diodes itself. That is why it is not possible to rectify 0.7 and less than that voltages. That is the one limitations. Okay, so because of that, so your precision rectifiers are comes into existence right now. So the rectifier is what we can say, the definition of the rectifier is already discussed. It is a rectifier which converts one form of energy, that is AC signals, to DC. Conversion of AC to DC is called as a rectifier circuit. Okay, as the rectifier circuit which is using the operational amplifier, here it is called as the precision rectifier circuit. So the rectifier circuit uses operational amplifier along with one diode, is called as a precision rectifier. What is the difference between this precision rectifiers and the diode rectifier is concerned? So precision rectifier will be rectifies the smaller voltage below diode drops, whereas the conventional diode rectifier is not possible to rectify the voltages below diode drops. Okay, that is the only one difference. So now some of the advantages. What are the advantages of these precision rectifiers or the diode rectifiers if you're talking about? So one is very smaller voltage can be rectified. Okay, that is less than 0.7 can also be rectified using the precision rectifier. And the second one is diode drop does not affect its operations. As you also are using along with the operational amplifier, we are using one of the diode. The drop across the diode will not play any significant difference in the operation of the circuit. That is another advantage. So third advantage is the amplification is required can be achieved. Whatever the in previous case, only the rectification is possible, whereas in this rectifier using operational amplifier, that is precision rectifier, along with the rectification, the amplification is also possible. Okay, and the next is it has a low output impedance. So these are the advantages. Because of these advantages, so precision rectifiers are most commonly used in some of the electronic application. Okay, next, so these precision rectifiers is classified, broadly classified into two categories, that is a half wave rectifiers and full wave rectifier. Precision half wave rectifier, precision full wave rectifier. So in this module we'll discuss about the half wave rectifiers, and then we'll go for the full wave rectifier operations. Okay, so first is precision half wave rectifiers are further once again half wave rectifiers is once again one cycle of AC is converted into DC. That is why it's called as a half wave rectifiers. So full wave rectifier means both the cycle of AC is converted into DC. Okay, so half wave rectifier, further this precision half wave rectifiers is classified as saturation type of the precision half wave rectifier and non-saturation type of the precision half wave rectifier. Okay, that is the this one. Next is we'll discuss about in detail how exactly the operation of the saturating type of the precision half wave rectifier. So this is the equivalent circuit of saturating type of the precision half wave rectifiers, and this is the output voltage waveforms. So half wave rectifiers you know already. So only one cycle of AC is converted into DC, other cycle will be 0. That is why it is called as a half wave rectifier circuit. So this precision half wave rectifiers can be designed using the voltage follower circuit by connecting the one diode in between the output voltage and the op amp. So that's it's a simple voltage follower network. Only one diode is extra is connected between the output voltage and the load. That is the difference. Now we'll discuss in the operation of this circuit. So when the input voltage, as it's a non-inverting type of the amplifier we are used here, so when the input voltage is positive, so when the input voltage is positive, op amp also the output voltage is also positive here. Okay, if the output positive, the diode anode will get the positive polarity, so it is forward biased, and it will conduct. So when it is conducting, that means, so whatever the voltage you applied will be coming as a output voltage. That means input voltage is equal to the output voltage. This is during the first half cycle. See here, you applied the positive, so positive will output, because of the forward conduction of the diode, positive will appear here, right? That is what the operation. So in the second case, so when the output goes negative, so when the input goes negative, the op amp output will be positive here. So sorry, okay, when the input voltage is negative, if you apply, so if you apply the positive, output voltage will be reverse. So if you apply the negative, output voltage will be forward bias. So in the second case, when the input goes negative, the output attains the negative saturation, okay, then the diode D1 is reverse biased. So if you apply the negative supply, so negative will comes. So as it's a non-inverting type, so if you apply negative, negative will come. So if the negative voltage across the anode will makes the diode to conduct in a reverse bias mode, in that case the output voltage will be 0 here, and this is the output voltage. Okay, so by interchanging the direction of the diodes, okay, so another half cycle of the rectification can also be possible here. Okay, so if you interchange the direction of the diode, so we can get the another half cycles of the operations here. This is how the saturating type of the diodes are operating. Okay, this is the working principle of saturating type of the precision half wave rectifiers. So here it is given, say here, so interchanging the direction of the diodes, the negative, so the diodes, the negative half cycle of the precision rectifier can also be obtained, okay, in which the positive half cycle of the input gets clipped off. Okay, if you interchange the polar direction of this diodes, will get the here the positive, and this will be 0. Okay, so positive half cycle you will get the, if you interchange this diode, so during positive half cycle you will get the 0 output voltage, during negative half cycle you will get the some output voltage. So that can also be possible by interchanging the direction of the diodes. So this is about the saturating type of the precision half wave rectifier. Similarly, the next kind is the non-saturating type of the precision half wave rectifier. So this is the equivalent circuit and the output voltage waveform of the non-saturating type of the precision rectifiers. So here also the operating principle is not much differs. Here the action of the diode will be carries the operation here. So when the input voltage is positive, okay, so here it is a inverting amplifier, so input is given to the inverting terminal. So when the input voltage is positive, the output voltage goes negative, output voltage will be negative. So if the output voltage is negative, the diode is reverse biased and the output voltage will be 0. Okay, so the input is positive, output is 0, that is during the positive half cycle. So when the input voltage is negative, so if when the input voltage is negative, the output voltage will be positive, that makes the diode D1 for D2 forward biased and D1 reverse biased. So in that case what happens, the output voltage will be, because we are using a resistance R1 and RF, so the output voltage will be V0 is equal to minus RF divided by R1 into Vin. So you will get the curve here. So in the similar way, so if you go on applying the input voltage, so you will get the continuous pulses, one alternating pulses at the output side. So when the input voltage, so when the RF is equal to R1, so the negative half cycle of the Vin is produced, so when the positive half cycle is at the output voltage. Okay, and thus the positive half cycle of the Vin is clipped off, okay, and only the negative half cycle will be appears at the output side. So that is why the controlled switching of this diodes will make the output voltage to vary at the rectifier circuits. So if you continuously apply the sinusoidal input at the R1, so that is at the Vin, you will be getting the alternative DC voltage at the output side. That is about the non-saturating type of the precision half wave rectifier. So the other part, rest of the things, problems on this and the design and other things, we will take up in the next video, right? Thank you.